welcome back. So last time we were doing how we can apply Laplace transform in order to solve transient circuits. And today what we'll do is we will see how we can solve the same question by using transform impedance method. Okay, so let us come on pen and paper. Recall that our circuit was like this. There was a 10 volts voltage source with a switch that was made close at t equals to 0. There was a resistance, an inductance, and a capacitance. Fine. So it was of 10 volts, 10 volts voltage source. This was of 3 ohms. This particular thing was 1 henries, and this was 0.5 farads. Okay, and the switch was made closed at t equals to 0. Now remember that the initial conditions have a big role to play, and the initial conditions were IL at 0 minus was equals to 0, as well as VC at 0 minus was equals to 0. Fine. These were the initial conditions. Okay. Now, what you have to do is all of these parameters or given things here are in time domain. You just have to convert the same circuit in S domain. Okay. So I have told you in last class itself that you can change a capacitance which was having value C in S domain. The equivalent circuit of a capacitance is this. And for example, let's say this is our VC in S domain. What was this value equals to? What was it?
1 by CS.
1 by CS in ohms. Okay, you should remember that. And this was a voltage source. And how do I write that voltage source? Plus minus this. VC at 0 plus upon S. Okay. I hope you all remember that particular thing. Fine. That's how we write the total voltage across these two things. Similarly, we also did that the equivalent of an inductance is with a current source. Fine. With a current source. Now tell me if this is, let's say, IS, and across this there is a potential of VL of S. What was the value in ohms for this?
LS.
It was LS. And what was the current flowing? Upward or downward? What was the direction?
Downward.
Downward, and the value of the current was?
I0 plus S.
I0 plus upon S. Right? I0 plus upon S. So these two things, along with the Laplace transform of this source, along with the Laplace transform of this resistance, we have to take. Let us do that. So by doing so, what we'll get is, what is Laplace transform of 10, by the way? Because it is constant. It is constant. So Laplace transform of a
It's
constant
10.
is
10 by S.
10 by S. So when you will convert your circuit in S domain, it would look something like this. I can now just omit this switch. Because of that switch, all of the things like the transform has occurred. So I have a resistance, an inductance, a capacitance, and a voltage source across capacitance. Or yahan se there was a current source across inductance as well. Fine. So this becomes the actual circuit with initial conditions. ये होगा और इनमें value हो जाएगी, इसकी value थी हो जाएगी 10 by S. But we know that although resistance was constant, लेकिन resistance का transform क्या रहता है? Remember what becomes the transform of resistance? हमने कल करके दिखा था. It remains S. It remains in S domain also equals to R. So it will not change. We can keep this as R ohms only. This is equals to LS ohms. This is equals to I0 plus by S. Because it is current, so it would be in amperes. This is equals to 1 upon CS ohms plus minus VC 0 plus by S. Now you know that because of our initial conditions, if I0 plus equals to 0, what should I replace this with? An open circuit or closed circuit?
Open circuit.
Open circuit. So this will be replaced by an open circuit. And what do I replace this particular thing with? A closed circuit. Okay.
Yes, sir.
So I would just be left with this thing, with all other things are in S domain. So I have a voltage source in S domain given by 10 by S. I have a resistance of value R ohms. I have inductance of value LS ohms because it is contributing to the impedance. And the value is 1 upon CS ohms. Now, the question was same, like you have to find out the value of voltage and current across all the elements. Over here, because all of these are in series, I can say that let's say some current is flows. Okay, and these three are passive element, this is an active element, and I say that the current is flows. So what would be the KVL equation for this particular circuit? So we can simply write that it is nothing but equals to 10 by S has to be equals to I, which is function of S into R, plus LS IS plus 1 upon CS IS. Okay, so it is just like इसके impedance से आपने I को multiply किया, you got the voltage across this. So all of these are nothing but, अगर इतना देखें तो it is VR in terms of S, ये देखें तो it is VL in terms of S, और ये देखें तो it is VC in terms of S. Okay, is it fine? So now you can solve this equation. We again got the same equation जो इतने सब कुछ करने के बाद आ रही थी last time. We got this equation and it is 10 by S is equals to, you can take a few things common from here. You have R plus LS plus 1 upon CS into IS. And you can now put the value of R, L and C. So R was equals to how much? 3 plus L was equals to 1 plus C was equals to 0.5. So 0.5 will go up. It would be 2 by S. Done. You can take it as IS. Now I can write this as 10 by S is equals to 3S plus S square plus 2 upon S into IS. So S से S हो गया cancel. You get IS is equals to 10 upon 3S plus S square plus 2. Okay. You got it in this way. And I am very sure you know how to solve it. Okay, you have to make it in partial fractions. You can just write it like, it can be written as 10 upon S plus 1, S plus 2, and then you can just equate it with some value S plus 1 plus B upon S plus 2, and you can take the Laplace inverse of these things by finding out the value of A and B. Put in the equation, you will get your value of current. Similarly, then for voltages across all the elements, you can use the same trick we did yesterday. Okay, so this is the approach which we call as using the transform impedance method, and you can apply any when you were asked to do or solve such questions in exam. Fine. Let us take another example in which you will have to find out the value of.
Sir,
हाँ, yes.
सर लास्ट टाइम हमने जो सारी आर की वी आर वगैरह की वैल्यू निकाली थी वो आई टी के टर्म्स में निकाली थी, इसमें हमें
Definitely.
ट्रांसफॉर्म लेना पड़ा था. अब इसके अंदर तो हमने डायरेक्ट आई एस के टर्म्स में निकाल दिए हैं, तो हम
No,
डायरेक्टली
that
आई एस की वैल्यू.
no, that I agree to what you were saying. See, you can go both ways. How would you solve this one? If you remember from last time, what was the value of 10 E coming out to be? It was 10.
Yes, sir.
So it was something like S plus 1 plus B was coming out to be minus 10, right?
Minus. Yes, sir.
S plus 2, and it was equals to IS, right? So if somebody is asking you what would be IT, You can take the Laplace inverse. You would say that it was equals to e to the power minus t minus 10 e to the power minus 2t. Is it right? And
Yes.
and a ut, because all happens if after t equals to 0. It is fine. Now, either you use this particular is and put it in this value to find out the voltage across it. अब इसकी unit क्या है? If you have taken not just L but LS, तो इसकी unit क्या हो जाती है? I told you last time. It's in ohms. तो ohms को IS से multiply कर दीजिए. So actually what you will get is your voltage across inductance in S domain is nothing but equals to LSIS. And what is L? 1. So it is nothing but equals to SIS. Fine. So either you go by this way. Now you take Laplace inverse of S upon S square, sorry, 3S square plus S plus 2. Either you solve this or you solve the same way we did last time. No problem. Both the way you can solve it. So once you have converted it into time domain, you can utilize the concept of time domain and then solve. Or you can try solving these particular type of equations and then you can solve. Okay.
Okay, sir.
So our main motive is to how we can apply the transform impedances in order to tackle our query or question. So abhi tak, whatever the type of questions we have done, whatever the type of questions we did were
सर
और
अगर मैं सिर्फ नेट इम्पीडेंस देख लूं, नेट इम्पीडेंस
हाँ हाँ so actually जब हमने IS calculate किया था तो it was net impedance only. Total R plus LS plus 1 upon CS is net impedance ना.
हाँ तो सर उससे ही बन जाएगी इक्वेशन में.
हाँ वही तो
हर
किया भी
केस में
है.
उससे बन जाएगी.
हर केस में उससे नहीं बनेगी. सी द वोल्टेज इज डिफरेंट अक्रॉस ईच एंड एवरी एलिमेंट. अगर इसके अक्रॉस वोल्टेज देखेंगे इट वुड बी IS अपॉन CS. ओके. इसके अक्रॉस अगर वोल्टेज देखेंगे इट वुड बी IS अपॉन CS. तो करके देखिए आप व्हाट इज VC, व्हाट इज गोइंग टू बी VC इन टर्म्स ऑफ S. तो देखिए इसमें करंट क्या फ्लो हो रहा है IS और इसका इंपीडेंस रेटिंग है 1 अपॉन CS. तो VC in S domain is equals to IS upon CS. What the value of IS we calculated? अभी S domain में IS क्या आया था? 10 upon 3S square plus
3s plus h square plus 2.
It was what?
3s plus h square plus 2.
So it was just S square और 3S plus 2. तो ये तो हो गया I. इसको 1 upon CS से और मल्टीप्लाई करना है. तो 1 upon CS से मल्टीप्लाई करने का मतलब है ये 0.5 into S. So ये हो जाएगा आपका 0.5 will go up as 2. So it would be 20 upon S square plus 3S plus 2. Now actually you have this S plus 1 S plus 2 3 terms. तो partial fraction करेंगे तो 3 terms आ जाएंगे. Now you have to solve it for A upon S plus B upon S plus 1 plus C upon S plus 2. You have to solve it all for all this. Okay? And this is nothing but equals to your VC as a function of S. Can you find out the value of A, B, and C? So as far as I look at it, it seems that A into S plus 1, S plus 2, plus B into S plus 2, plus C into S plus 1 should be equals to 20. All right. So I have just taken LCM both sides. I hope this step is clear. If you say that you have done 4th semester course in mathematics, this step should be clear. Okay. I've just equated with 20 upon S plus 1, S plus 2. Taking LCM over there, multiplying all the common terms and got it. Do you all agree to why, from where I have got this term?
Yes, sir.
Okay. Then apply putting, if you want to find out, let's say, value of B, what you would do?
-2.
So you can put, if you want to find out value of B, put S equals -1. So when you would put S equals -1, this will cancel, this will cancel. Because S I have taken as -1, you will have -1 into B, which is minus B. 2 plus -1 is 1. तो minus B is equals to 20. तो B की वैल्यू क्या आ गई हमारे पास? -20. Similarly, you can solve for A. ए के लिए यू पुट s इक्वल्स टू 0, तो ये दोनों 0 हो गए, ये हुआ 1 into 2 is 2, 2, तो b आ गया, a आ गया हमारे पास 10। सिमिलरली c के लिए s इक्वल्स टू -2 पुट कीजिए, -2 पुट करने से ये गया, ये भी गया, तो -2 + 1 is -1, -1 into -2 is +2, तो +2 डिवाइडेड बाय 20 करेंगे तो c की वैल्यू भी 10 आएगी, तो a की वैल्यू 10, b की वैल्यू -20, c की वैल्यू 10 आ गई। ठीक है, एक बार चेक कर लीजिए आप लोग। This is it. Now you have this thing with you. It is 10 upon s plus -20 upon s plus 1 plus 10 upon s plus 2. And this is your VC of s. Now you have to take the Laplace inverse of this equation. What would be the equation finally? 10 e to the power minus t minus 20. So it would not be even t to the power minus t. यहाँ कोई जीरो थोड़ी है, ये तो 10 ही बचेगा, क्योंकि 1 upon s का Laplace inverse क्या होता है?
1.
तो 1, that's it. अब इसका बताइए, 20 e to the power minus t हो जाएगा प्लस 10 e to the power minus 2t, करेक्ट? और इसको आप ut से मल्टीप्लाई करते हैं, यू विल गेट योर VCS। ओके, डूइंग द सेम वे वी डिड, लेकिन लास्ट टाइम हमने क्या किया था, हमने एक KVL लगा के उसे अप्लाई करके देख लिया था कि हमारी जो VC की वैल्यू होगी वो 10 माइनस VR प्लस 10 माइनस VR माइनस VL इक्वल्स टू VC। वहां से करेंगे तो भी यही आएगा, 10 माइनस ऑल दोस थिंग्स। ठीक है, but this is another way of solving things. Are you getting it?
Yes, sir. We need to give the answer in time domain only.
Yes, that is for true, because it is required that you solve it for all t's. No one is going to check whether how value progressed in s domain. You could have just solved the differential equation, because we want time for all t's. We want to plot for t, we want to plot the function for t, what happens at t equals to something greater than 0. Okay, let us take another example, and this example is going to be quite different from what we are doing since 2-3 days. Here the initial conditions will not be 0, so you might have to use some of the common sense. So we can call it as example 2. Okay, and this example 2 I will just take as a separate recording. Okay,